Hey everyone! Now that we've kind of gone over general chemical reactions and what are reactants and what are products, in this mini lesson we're going to learn how to balance chemical reactions. So as a little bit of a review on the last lesson, there are two types of numbers that can be found within a chemical equation. The first one is called a subscript, and these are just small numbers that come after a chemical symbol. So for example, if you have CO2, these are going to tell you the number of atoms of each element. If there is no number down here, it's an understood 1, and then this one tells me that there are 2 oxygen. One thing to note is if you change any subscript number, you're going to change the entire compound. For example, there's a difference between H2O versus H2O2. H2O is drinking water, but H2O2 is hydrogen peroxide, which is a cleaning disinfectant. Number 2 is a coefficient. This is a number that's placed in front of the chemical symbol or formula, and it tells you how many molecules, ions, formula units, or atoms you have as a whole. So typically you might see 2 H2O. So this tells you that there are 2 water molecules. So the coefficient goes to every element in the compound. For example, if you are saying water, which is H2O, if I have a coefficient of a 2, that means 2 times 2 gives me 4 hydrogen, and then 2 times 1 oxygen gives me 2 oxygen here. Down here, if we were looking at the example, calcium hydroxide, which is this one right here, there are 3 calcium because there's an understood 1 down here. But there are 6 oxygen because the 2 is going to oxygen, but also the 3, so 2 times 3 is 6. And then for hydrogen, there are also 6 because of the 2 from outside the parentheses, and then again the 3 here. So as a little bit of introduction, first semester we learned about a law known as the law of conservation of mass. And this law basically stated that in any physical or chemical change, mass is conserved, which means that mass cannot be created and it cannot be destroyed. So here's a good example that we saw first semester of this happening. Note that we have 2 liquids and they weigh 43.43 grams. If we actually pour those and mix those together, note that the mass after they were mixed or after they underwent a chemical reaction stayed the exact same, 43.43 grams. So in other words, the mass of the reactants and the products are the same, and the same thing happens with atoms within a chemical equation as well. We want to make sure they are conserved or stay the same. So a chemical equation is a representation of a chemical reaction. For example, the one below, iron reacting with oxygen gas, yields Fe2O3, also known as rust. This is just a general chemical reaction, but in order to make it a balanced chemical reaction, we want the same number of atoms of each element the same on both sides to show that mass is being conserved. So if I were to write this as a balanced chemical equation, I would have to put the coefficient 4 here, 3, and then 2. And that's because if we look up at the regular equation, I have 1 iron on the left and 2 oxygen. 2 oxygens. Over here, I have 2 iron and 3 oxygen. So notice my iron don't match up and my oxygen don't match up. And so it's considered unbalanced. But down here, if we look at this chemical equation, we have Fe and O. We have 4 Fe's, and then 3 times 2 gives me 6 oxygen. If I look on the right side of the balanced equation, we're going to see that I still have 4. 2 times 2 gives me 4 Fe. And then oxygen, 2 times my 3 oxygen gives me 6. Again, note that each element is the same on both sides of that chemical equation. So what are the steps that you have to take to balance your own chemical reaction? First, the only thing that you are allowed to change is the coefficients. We use coefficients to balance the equation so that it obeys this law of conservation of mass. The coefficients should also be in the lowest possible whole number, which means they need to be reduced. Also, please note, never ever change the subscripts. Again, if you change the subscripts, you're changing what that compound is, not how many. So carbon burns in the presence of oxygen to produce carbon dioxide. This equation is considered balanced because if we look on the reactant side, we have 1 carbon, 2 oxygen, and if we look at the product side, 1 carbon, 2 oxygen. You don't need to change any of the coefficients. They're all understood to be 1. However, when hydrogen and oxygen gas are mixed, the product is water. Here on the reactant side, I have 2 hydrogen and 2 oxygen, but on the product side, I have 2 hydrogen and 1 oxygen. Notice here that the oxygens are off. The formulas for all the reactants and products are correct, but this is not considered to be balanced because oxygen is off. So then we ask ourselves, what could we do? Well, what we could do is we could try to put a coefficient 2 in front of H2O. So here is my 2, and then we have to see how did that change my number of atoms. We're going to see that that gave me 4 hydrogen atoms and 2 oxygen atoms because that 2 gets distributed to my oxygen. Now notice how my oxygen are balanced, but my hydrogen are not. We now have twice as many hydrogen atoms in the products than our reactants. So what else could we do? Well, to help counterbalance that, we could actually try to put a 2 in front of the H2. Notice now that gives us 4 hydrogen on the left, 4 on the right, 2 oxygen on the left, 2 oxygen on the right. This equation is now considered balanced. You're going to note that balancing is a little bit of a trial and error. But there are some tips that I can give you for balancing chemical equations. First, we have to determine the number of atoms on each element in the reactant and products. So how many of each one do we have? With that, polyatomics, I have a polyatomic chart that I've given you. One thing to note about them is that if we try to keep those together, we can count them as a single unit if they appear unchanged. For example, if you see this on the product side, 2 outside the parentheses, we can actually keep NO3 together and say that there are 2 NO3s and just put the coefficient there. Another one that I can tell you is balance elements that appear only once on each side of the chemical equation first. So also, if you have a lone element such as aluminum or H2 or O2, try to save these to balance last. Lastly, once you believe you have the correct answer, please make sure you check that the atoms are equal on both sides and then reduce if you need it. It's a little bit of a trial and error. So let's do this example first. I'm going to go ahead and split this in half because that's what I like to do. And I'm going to list these elements. I've got Ag, N, O, and Cu all on the left-hand side. And I should have the same exact elements on the right-hand side. You may have to take out a piece of paper and do this on a scratch piece of paper, and that is fine. Now, next thing I'm going to do is I'm going to count up how many of each element that I have. Here I have 1 silver, 1 nitrogen, 3 oxygen, and 1 copper. Over here I have 1 copper, and then I have 1 silver, and then here it's showing that I have 2 nitrogen and 6 oxygen. So you should notice right off the bat that our nitrogen and our oxygen do not balance. But you should also realize that nitrogen and oxygen are both within a polyatomic, NO3, that is nitrate. And so what you can actually do to help balance this is if you see this 2 outside the parentheses, we want to balance that same polyatomic on the other side. So what we're going to try to do is put a 2 in front of here. Now we have to see how that affects things. Notice here it's going to affect my silver, and I now have 2 silver. If I distribute this to my nitrogen, note that I have 2 nitrogen. And if I distribute this to my oxygen, I have 3 of them. 2 times 3 gives me 6. As you can see, I have one step closer to balancing this chemical equation. The only one that is off is my silver. Note that this is also a lone element, and Everything else is balanced, so let's try balanced silver. If I have 2 silver on the left, in order to get 2 silver over here on the right, I'm going to put a 2 in front of here. Notice that only affects my silver, and see that I have everything else is balanced. That means my coefficients in front of my other ones are going to be an understood 1. Here's another example of us balancing a reaction. So I like to again split it in half and list the elements I have. I have carbon, hydrogen, and oxygen. Here I have carbon, hydrogen, and oxygen. Now we need to count up how many elements on each side that we have. Here, if I look at carbon, I have 3 of them. Hydrogen, I have 8. And this oxygen, I have 2. Over here, this carbon, I have 1. But notice this oxygen, I have 2 oxygen from here plus my 1 oxygen from here. So I actually have 3 oxygen and then 2 hydrogen. So what you're going to notice first is that none of these match. So where do I start? If we start off with our tricks, we don't want to try to balance something that is in 2 different spots. So notice my oxygen are in 2 different spots. So I'm not going to focus on that one first. What I'm going to try to focus on maybe is to look at this carbon. If I have 3 carbon over here on the left, let's see how this affects over here on the right by putting a 3 here. Notice that this is going to change this to 3 carbon, but my oxygen also changes. 3 times 2 gives me 6 oxygen, plus my 1 over here gets me 7 oxygen. Okay, now I have 1 of 3 things balanced. Let's focus on the hydrogen next. So over here, no, I have 8 hydrogen, but over here I have 2. So 2 times what number could get me 8? And you might say 4. So 4 times 2 can get me my 8 hydrogen. Note that that 4 also affects the oxygen over here. So let's recount my oxygen. 3 times 2 gives me 6, plus my 4 times 1 gives me 4. So 6 plus 4 gives me a total of 10 oxygen on this side. Now if I look over here, 2 times what number will get me 10? 2 times 5 will actually affect and get me 10. And so it's a lot easier to balance this one since it doesn't affect any other element last. That's why I always tell you to save the single element for last. Now everything's balanced, and this is an understood 1. This one looks a little bit harder, but again, we're going to focus on the same things. Here I'm going to list the elements that I have: calcium, oxygen, hydrogen, and phosphorus. Calcium, oxygen, hydrogen, and phosphorus. We're going to still list each element that we have on each side. So notice here I have 1 calcium. I have 2 oxygen from here, plus my 4 gives me 6 total oxygen. My hydrogen, I have 2 from here, plus 3 gives me 5 hydrogen. And then my 1 phosphorus. If I look over here on the right-hand side, I have 3 calcium, 2 phosphoruses, and then 2 times 4 gives me 8, plus my 1 over here, 9 oxygen, and then I have 2 hydrogen. This is one where you're seeing parentheses, so we're going to be messing with polyatomics. And notice that I have a PO4 and then a PO4 over here. So if I see a 2 outside, we want to balance that. So I'm going to put a 2 right here. That gives me 2 PO4s. Let's redistribute and count how many atoms we have. So here I have 3 times 2 gives me 6 hydrogen, 7, 8 hydrogen now. Here I have 2 phosphoruses now. And then I also have 8 plus 9, 10 oxygen. Okay. Then we can go and see what else we can balance. Let's try calcium because that seems like a good bet because it's the only one that doesn't have 2 elements. So calcium, I have 3 on the left-hand side. So here I have 3 on this side. And let's see how that shakes out and affects my other stuff. Here, you're going to see calcium changes to 3. 3 and 2 both go to this, so notice here I now have 6 oxygen plus my 8 oxygen over here. So 6 plus 6 is 12, 13, 14 oxygen. My hydrogen also is going to be affected. So 2 and 3, that gives me 6, plus 6 over here gives me 12. And then my phosphorus is not affected. And now you're going to be like, well, now I only have phosphorus and calcium balanced. How can we balance hydrogen and oxygen? Well, the easiest way to balance it is look over to the right and what has both hydrogen and oxygen. And you're going to notice that water does. So we need to balance water in such a way and where we get the same amount of hydrogen. So here I have 12 on this side, but 2 on this side. So 2 times what gets me 12? And you're going to say 6. So here I now have 12 hydrogen. And let's add our oxygens up. Here I have 8 oxygen plus 6 goes to my oxygen as well. So that also gives me 14 oxygen. Note here that everything matches up. So I have a 3, 2, 1, 6 for my balancing. And that's the end of today's lesson. If you have any questions, please make sure you ask. And otherwise that, I hope you guys have a great day.